All right, you guys, so what is the standard deviation? And you should write this down because you're going to have to interpret the standard deviation. And so it's how far, on average, the observations are away from the mean. Okay, the average distance away from the mean. All right, so there's two things you want to know, variance and standard deviation. Variance is the standard deviation squared. Okay, so this lovely formula, you want to label some stuff so that you know what it means. This little s sub x, if you just have s sub x, that's standard deviation. And then if you square that, that's the variance. And so it's s squared sub x. The first thing you have to find is the mean whenever you're doing variance and then standard deviation. And what this formula is telling us is you're going to take your first data point. This is the first observation. And then you're going to subtract the mean. This is x bar right here. All right, so it's the first observation minus the mean, and we square it, plus the second observation minus the mean, and you square it. And then you do every single observation minus the mean squared, the sum of that whole thing. And you divide by n minus 1. All right, n is the number of observations, right? It's rough this morning. Okay. This means the exact same thing right here. So we're still dividing at the end by n minus 1. This is the sum, right, that Riemann sum, of every single data point minus the mean squared. That's what the shortcut formula is saying. And then to find the standard deviation, you just take your answer, or your whole entire thing, and you square root it. All right, so here's the formula for standard deviation. That little s sub x is the square root of the sum of the data point minus the mean squared plus the data point minus the mean squared, blah, 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 all divided by n minus 1. All right. Have you guys done this formula before? I think you did this in like algebra 3. Is that right? Sure, yeah. Great news. All right. So here we have the number of pets owned by 9 students. Okay. And what are the observations in the data set relative to the mean? Okay. What are the observations in the data set relative to the mean? What is this asking for? It's asking for the standard deviation. Okay. So the first thing you have to do is actually find the mean. So, of course, add all these up, right? And divide by what? 9. All right, and so you end up getting that x bar is 5. So the average number of pets is 5. I have a lot of pets, all right? And now we're going to find the standard deviation. And we can start with the variance. And then we'll square root our answer at the end, okay? And so we take the data point, number 1, and we subtract the mean, and we square it, plus the next data point, minus the mean, squared, plus the next data point, minus the mean, squared, blah, 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 right? You get to do that dot, dot, dot thing. And then 9 is the last one, minus the mean squared, all divided by n minus 1. What's n? All right, 9 minus 1, so all divided by 8. We end up getting 52 divided by 8, which is 6.5. Again, this is called the variance, which you do need to know. All right? And the variance is always the standard deviation squared. So then to get to the standard deviation, we square root. So this is just s sub x. And I'm going to square root 6.5. And so my standard deviation is 2.55 pets. Then you have to interpret it. So write one sentence on what the heck that means. This is the average distance from the mean. And so you would say something like, the number of pets typically varies from the mean by 2.55 pets. All right, some important facts to write down about standard deviation. So you should write these down. S of x measures spread about the mean and should only be used when mean is chosen for the measure of center. So write this down. You need to always do mean with standard deviation. Colin, you with me? Oh, good. Write this down. So mean always goes with standard deviation. If you're doing the mean, then you want to talk about the standard deviation for the spread. If you use mean for your center, use standard deviation for your spread. In other words, if you use median for your center, then you can use IQR or range for your spread. Those guys are friends. Okay? Those go together. But if you're doing the mean, use standard deviation. All right. So the standard deviation, S sub x, is always greater than 0. It is always positive. Why is it always positive? Because we're squaring everything, right? So we square all the negatives out in that formula. When is the standard deviation 0? When is the typical distance from the mean 0? Yeah. Right, if my data, like every single person I know has one pet, right? What's the average distance from the mean? 0. There's no distance from the mean because the mean's 1 and everybody's 1. So if all your data is uniform, you're going to have a standard deviation of 1. All right, this is important. Standard deviation has the same units of measure as the original observations. So if I'm talking about pets, standard deviation is also talking about pets. If I'm talking about inches, standard deviation is talking about inches. All right? And the last thing that's really important, standard deviation is not resistant. When we're talking about resistant, we're talking about extreme outliers, all right? So we have crazy cat lady that has like 50 cats, right? Is that going to change our spread? Yeah, the average spread is drastically going to increase because of crazy cat lady, okay? So it is not resistant. What is resistant is definitely IQR, not range though, okay? But IQR is. So should we choose the median and IQR or the mean and standard deviation to describe data? Write this down. If you have skewed data, which one should you use? We kind of talked about this yesterday a little bit. Yep, if you have skewed data, then you need to use the median and IQR to describe your distribution. Okay, so look and see if you have an outlier or look at a graph. And if you have roughly symmetric data, you can use the mean and the standard deviation. Okay. by hand, probably like once or twice in the homework, and then I'm going to show you how to do all this on your calculator. So you can just get all the values really quickly. Yeah. Your calculator does one variable statistics. You guys remember, have you ever used that when you plug in a bunch of data and it calculates like all the stuff you would need for a box plot or for standard deviation? It's great. As long as you entered the data correctly. What? All right, so we're just kind of introducing you to what's called the 4-step process. I would just write down state, plan, do, conclude. You're going to do a lot of these. State, plan, do, conclude. So for state, you're going to state what the question is you're trying to answer. For the plan, how are you going to go about solving it? Do, actually do the problem, like make some graphs, do calculations, and then conclude. Write a conclusion, always relative to what we're talking about. What'd you say, Cody? Yes. It is surprising how much writing some of the problems are. What'd you say? Yeah. Yeah. I know. Okay. So who has more contacts in their phones, males or females? So we would talk about this doing the 4-step process. Also, I'm going to show you how to do this on your calculator to get all the data. Yay. So you might want to grab your calculator. We would do the whole state, plan, do, conclude. So can anyone come up with a good question we would use for the state part? You don't need to write this down, but just come up with a question we could use. Yeah. Okay, I would take that. Good. Awesome. Way to go. And for the do part, this is a little vague, or the plan part. We're going to compute all the summaries we need, right? Everything we need data-wise. And then we're going to graph parallel box plots. That's just the way we're going to do this one. You could choose to do it differently. And compare the stocks, shape, center, spread, and outliers. All right? So we're comparing the distributions using our stocks. Yay. All right. So let's see if we can do this. Make a couple notes here on which calculator you have so I can change it back to the data. So write down what you need to do. You're already ready to go. So after you enter the data, you might want to make note what you do. If you have the 84, you do second quit, stat calc, one variable statistics. You have to actually put the list in, depending on which list. Yeah. If you have the Inspire, after you plug it in, you can just move your cursor to a blank box. All right, move to a blank box on the spreadsheets, and then you just hit menu, stat calc, one variable statistic, okay, and then which list. So you have to put in what you titled your list, males or females, okay? You can also do the one variable stats on the blank screen if you have the Inspire. But I usually just do it in the grid, so just like arrow over to a blank box, and then you can do that same thing. Everybody have a note written down on what to do so I can go back? All right. Let's see if we can enter the data. All right, so state, plan, do. I wrote down all the data from my calculator, right? And I drew some box plots. Yay. All right, and then we have to do our socks. Oh, so I'm going to call on you guys and see if you can do this. Compare, all right, the distributions. When we're talking about shape, compare them, or talk about if they're the same shapes, different shapes. So if you remember from yesterday, so let's go, Jordan. What do you think the male shape would be in this guy? Very good. We have a longer distance from here to here. So the male distribution is skewed right, all right? And Mitchell, what do you think for the female distribution? Yeah, I would go with roughly symmetric. However, if you said skewed left, I'd take that too. All right, I would go either way. All right, and so we compare. And now we've got the center. Let's just look at the median, compare the median. So Jack, what do you think for the median? Yep, So greater than. So do it in the context of the problem. That means females have more contacts than males on average. Okay? And then we've got the spread. So when doing spread, I would talk about IQR or range. So compare those two. Let's compare range because that's a little more obvious on this one. Colin, how would you compare the range of the male distribution to the range of the female distribution? Right. So that means that the males' number of contacts on their phones varies more so than the females in our data set. Okay? And outliers, you actually need to check for them with your formulas, which is, I know, a lot of work, but neither has outliers. Okay? And then we conclude. So make some sort of conclusion based on the data. In the samples, females typically have more contacts than males because both the mean and the median values are slightly higher. However, is it significant? Not really. And we're going to talk about how to prove whether something's significant or not next semester a lot. But for now, you can just kind of look and say, well, it's not that much greater. And so it's not really convincing evidence that one gender has more contacts than the other. Okay? All right, you guys can write this down.